We are now going to venture into an area of discrete mathematics called number theory. And it sounds maybe somewhat dry at first, but number theory is really the study of the integers. And the study of integers is extremely important for a number of reasons, but one, when you think about crypto systems or cryptography, the act of encrypting information, so whether that is an RSA encryption, 128-bit or 256-bit encryption, the way that process takes place is via number theory. So without understanding number theory, cryptography is sort of this vague science. So we'll address in this particular video some of the very basics of number theory. And the very first one is this notion of divisibility. So at first, a lot of these topics will remind you a lot of what you have done in grade school, where working with numbers was sort of just a common thing. So when we think about divisibility, or what it means for something to be divisible, for instance, if I take 6 and I divide it by 3, then what I get is an integer, right? I get an integer because of the fact that 3, we can extract 2 copies of 3 from 6. So we can think about this as 6. Okay, how many times can we subtract away 3? Well, we can do it once, and that gives us 3. And then we can subtract away 3 again, and that gives us 0. And so we have no remainder left. And when that is the case, whenever a number like 3 can go into another number an integer number of times, then we say that that number is, that 6 is divisible by 3. So we'll say 6 is divisible by 3. Now we could do that for any set of numbers. We could say, well, 12 divided by 4, that results in an integer. In other words, I could take 12 and remove packets or bundles of 4. I could do that 3 times before I run out of packets. So this could be that we could think about 12 as I have 12 cupcakes. Let's go with cupcakes. Cupcakes are fun. So if I have 12 cupcakes, that means if I'm going to give away packs of 4, I'm capable of giving away an integer number of packs. I can give away 3 packs of 4 cupcakes. Now this may seem very trivial and petty, like something you've encountered before, but thinking about it this way is going to become extremely crucial. So we would say 12 is divisible by 4. Okay, great. And we can come up with examples where that's not the case. For example, if I try to divide 7 by 3, well, first of all, if I think about this in terms of repeated subtraction, how many groups of 3? If I have 7 cupcakes and I want to give away, these beautiful plates of 3 cupcakes, well, I could do that once. I have 4 cupcakes left. I could do that again. I have 1 cupcake left. But the problem now is that this is my remainder, right? This is what I have left. And unfortunately, I can't create any more bundles of 3 cupcakes. So this is not an element of the integers. 6 over 3 is an element of the integers because it's equal to 2, and 2 is an integer. 12 divided by 4 is an element of the integers because 12 divided by 4 is equal to 3, and 3 is an element of the integers. But 7 divided by 3 does not. 3 does not go into 7 an integer number of times. So here's how we often write this. Okay, so we say that 3 divides 6. So this is new language. 3 divides 6 means that 6 divided by 3 is an integer, or that 6 is divisible by 3. And the way we often write this is we say that 3 divides 6. Now that's a Boolean statement. It is either true or false. In this case, 3 divides 6 is a true statement because, again, 6 is divisible by 3. For our second example here, we can say that 4 divides 12. So it can evenly divide the 12 units into integer number of groups, and so we could write that 4 divides 12. This This vertical line has nothing to do with sets insofar as it just means divides. That vertical line is read as divides. So 4 divides 12. And then finally, we can say for this last example that 3 does not divide 7. And how do we indicate that? Well, oftentimes when we think about equality and things aren't equal, we just take the equal sign, we put a slash through it. So what we'll do here is we'll say 4 does not divide 12. So we just put a slash through it, we put a strike through it to indicate that 4 doesn't divide 12. So we're ready to formulate our official definition. If a and b are integers with a is not equal to 0, we say that a divides b if there is an integer c such that b equals ac, or equivalently if b divided by a is an integer. So this is kind of a loaded statement, but really what we're talking about here is that if b divided by a equals some integer c, okay, so some integer c, if the division of these two numbers produces an integer, then alternatively, this also implies that if you multiply both sides by a, that means that b is an even number of multiples of a. Okay, so for example, when we wrote 6 divided by 3 equals 2, we also could have said 6 is equal to 2 times 3. In other words, we can take 2 multiples of 3 or 2 factors of 3 out of 6 evenly. And so this is just another way of writing it, or you could say b equals ac. So basically we can confirm that b is some multiple of a, some integer multiple of a. When a divides b, okay, now we said here that a can't be 0, and the reason for that is because you'd have a division by 0 error. When a divides b, we say that a is a factor or divisor of b, and that therefore b is a multiple of a, right? If you multiply a by a certain number of times, you can get up to b. Just like here, we can take 3 or 2 multiples of 3 to get 6. So therefore b is a multiple or 6 is a multiple of 3. The notation a divides b denotes that a divides b. We write a does not divide b, or strike through that line when a does not go into b evenly. And that's the essential, the very, very preliminary idea behind number theory.